If I ask you to tell me what are the things you see in the sky, you will say there are stars. And sometimes if you use a telescope, you will also find galaxies and other things. So if I ask anybody where the whole matter in the universe is located, you will say it must be in stars and in galaxies. But in reality, it is not true. More than 80% of the matter we think that are created during the Big Bang is not seen because they don't emit light. And these are not dark matter, these are normal matter. Since they don't emit light, you will not see them. Best example is if you go to a remote place and look at the dark sky, when there is no moon, you will not be able to say whether there is cloud there or not, right? Because cloud is like gas which doesn't emit anything on its own. So how do you know such gas is present all over the place? We know them because if you look at any star or any object in the sky, the light from that object passes through the whole universe before coming to you. On its way, if gas is present, it will pick signatures of this gas in the form of absorption lines. So what we do in IUCAA, myself and my students, is that we use distant objects and look at their spectra and actually identify what all the matter which is present between us and that object of our interest. We use them for various purposes. For example, we use them to study the universe itself, how the universe is created, how it is evolving. We used to study how a black hole grows, means like black hole will be keep on eating up gas around them, how fast gas is falling into the black hole, or when two galaxies merge with each other, what happened to this gas which is surrounding that. All these things are done with a simple technique. We look at background sources, take the spectra, and then analyze the spectra to understand what's physics which is going on in these regions. Of course, just using a data alone is not sufficient to draw conclusions. We have to actually simulate the same thing in the laboratory. So in addition to doing observations, we also carry out what is now known as large-scale hydrodynamical simulations, where we actually simulate the universe and mimic the observation by putting a star or bright quasar behind that universe and see if the light goes through such a universe, what you will see. So these are the things we perform, and we try to conclude about the evolution of the universe and origin of the universe using these observations and simulations. Thank you.